Hey, this is Don from Padlock Technologies again with another video. This is going to be hopefully a quick video, but I got a question about Confederation versus route reflection. Which one should you use? Why should you use them? And some of the pros and cons of each, right? So this is more of a network design question. So we're going to go to the blackboard here. I'm going to draw out the two differences. So hopefully once you get this answer, you'll be able to pick which one you want to do. So let's go ahead and go to the whiteboard here or blackboard and go from there. All right, here. So the first thing we're going to talk about is route reflection. Route reflection is a technique that you want to use when you do not want to do IBGP full mesh, right? Because the requirements for IBGP full mesh is a pain. Let me draw that out. So the IBGP full mesh requirements is n minus 1 divided by 2. And again, I said in another video that this is the same formula for symmetrical encryption. So if you're using symmetrical encryption, follows the same formula of how many symmetrical keys you're going to use. So what route reflection does is it gets rid of this, okay? Because now when everybody goes to the route reflector, you don't have to have a full IBGP mesh in your environment. Now, what does that look like? So this is normally what you're going to see, especially if you're doing the CCIE. You're kind of learning this for MPLS purposes because you're probably going to end up doing some type of MPLS somewhere in a lab or something like that. That's what they normally do, but you know, things have changed, so I can't really say what you're going to run into, but it's also good to know. So say we're just going to have an MPLS network here, right? We'll have some PEs. And remember, MPLS is just a transport to transport technology, technically. And you're doing your transport based on labeling and not the IP lookup, right? So you're doing a label lookup versus an IP lookup, and the label is 20. Remember that if we're looking at the MPLS label, I know this is a side question right now, but it's 20 for the label, 3 for the experimental bits, which is QoS, 1 for bottom of the stack, and then 8 for TTL, which equals 32, but you're only doing your forwarding lookup based on the 20-bit label versus IP, which is the 32-bit lookup. Well, that's why it's faster, so to speak. So in this situation here, you would have to have a full mesh. Let me use a different color here. You would have to have full mesh like this. Everybody would need to have some type of adjacency towards each other. Now, as you can see, as this is only 4 PEs, you add something like 500, you're definitely going to have a problem, right? Because then it'll be 500 times 499, because that's n minus 1 divided by 2. I don't have a calculator on me, and I don't plan on doing that math in my head right now, but that's how many adjacencies or neighborships you would need to have full mesh, right? As you expand your MPLS or your just BGP environment, because it doesn't technically have to be MPLS, it could just be, global BGP, no MPLS, nothing, right? But you would have to have all those adjacencies. And what you're trying to do is avoid this nonsense here with route reflector. So what you would have over on the side is, let's say you have some stuff in the middle, you have route reflector 2 and then route reflector 1. You should always have some redundancy on the route reflectors, right? And then instead of everybody peering to each other, you're going to peer to the route reflectors. Okay. Right. Now, obviously, the route reflectors will have something called a cluster IP or cluster address, right? And the cluster address is really to avoid, right? Really to avoid these two from just injecting each other's routes, right? And then you have another address that when the PE see it, if it comes back to them, they will automatically just disregard the route. All right. So you'll have your cluster address and stuff like that in there, and then you'll have another originator who originated the route originally. So if it goes to a route reflector, it gets reflected back to the PE. Hey, I see my own IP in here, so I'm just going to drop it. Now the problem, or the pros is, again, the pros is you don't have to do this nonsense anymore, right? Cons of this though is, depending on how many PEs or how many routers you have. I always say PE because I just automatically go to MPLS stuff, right? But depending on how many routers you have that are going to do these route reflectors, these route reflectors better be pretty good, right? It better be pretty stable. You don't want instability in your network because the reflectors can't handle all those adjacencies. That's number one. Number two, the best path is from the viewpoint of each route reflector. So as we reflect routes in, does its calculation, and then it says, okay, here's your best path. But it's based on my viewpoint and not the PE viewpoint, right? Where can that be a problem? Well, if your exit point is literally right next to you, right, this is the egress, right? Right next to you. Well, if the route reflector says this, like, egress point is better, this PE, instead of going to, let's see here, where are my colors at? I don't like that one. There we go. Instead of going to this egress point, it ends up going all the way through your network and going over here because a route reflector said that was the perfect. Well, let me do this. It goes there because it says, oh, the route reflector says that's the best path. So I'm gonna go over there. So you can have some non, you can have some routing that's not optimal, non-optimal routing because the route reflector says this is the best path compared to something that could be right next to you. What fixes this issue? Optimal route reflection. I will put a card of the optimal route reflection video. It's a theory that basically runs CFPS from, or it runs the SPF algorithm, reverse SPF. That's basically what it's called. And it'll say, okay, instead of making the route reflector the tree or the root, I'm going to run it from the PE. All right. And then I'm going to give you a best path based on what you see, which is what the PE sees, and not what I see as the route reflector. So that's how you can get around that using optimal route reflection. So that's pro con. So the next one we're going to talk about here is Confederation. So BGP Confederation. So a BGP Confederation, think of this as little islands, right? So you have little islands, and then you have the main big island, which is, all right, let me say this. You have states, and then you have America, right? So the states have their own little thing going on, and then America is what everybody actually comes to, right? But it would look like this. So you would have, say, we'll do 3 here. We'll have 3 over here. And these are going to be little mini clusters of BGP, right? And here. Then you have the overarching, let me make sure I draw this correctly so you can see it. So you have the overarching AS, right? So each of these would technically be its own AS. So say this was 65005. This was 655002. This one over here is 65003. But to the outside world, let's say you had a connection here, connection up here, connection over here to the outside world, and they were connecting in this way. This AS would be, say, I'm just going to use internal stuff. You could use your public ASNs, but I'll just use private just to do this point. This could be 65011, right? So when you do your peering to the outside world, this is going to be peering to 6500 or 011. Same thing here. Its neighbor is going to be our remote AS is going to be 65001. That's what it's going to be peering to, right? Which is the ones in yellow. Now, what these guys are going to do is they're going to form a confederation like peering, right? So they're going to have a confederation ID, and then they're going to have a confederation here, right? and you're going to set that up. And let me use this. Here is going to be, say the ID, you're going to have your ID is 65003, and then your peers are 65002 and 4. All right. So that's going to be the peers. Peers is 65002. I did say 2, right? 2 and 1, sorry. So 65001. All right. For the red is going to be 65003, 65001. And for the white, it's going to be 65002 and 65003. Right. Now, when you see the AS path in here, you're going to see some real wonky, not even say wonky, but you just got to know what you're looking at. So say the ones in the green were, 65008 everywhere. So obviously, if they have the same ASN everywhere, you're going to either have to do AS override or you're going to have to do allow ASN, right? Depending on what you want to do. If you do AS override, you're basically just overriding the AS number from the service provider standpoint. If you do allow ASN, you are accepting stuff with your own AS path in it, right? And if you know BGP loop prevention, then anything that has your ASN number in it, you automatically just disregard it because that's preventing the loop. Now, what's going to end up happening in the AS path, you will see something like this. You will see 65008 parentheses. Let's say it was coming from this way and going to here. Parentheses 65003 and then 65002. So you would see your Confederation peering adjacencies in parentheses, right? Because what happens is it goes through all of these. So traffic would go through peers here, goes to here, it would hit this ASN or hit this little Confederate cluster, go through here, go through here. But when it comes out, these private ASN numbers are stripped off. So technically what this would see is 65, since I'm gonna say I'm using AS override. So if I'm using AS override here, what it would see in the ASN, in the AS path would be 65011, 65011. All right, that's what it would see in this path. All right, because if you for some odd reason, if the AS numbers or AS path included the Confederate peering, there would be a problem, right? You would have a major problem in this. So that's why when you do Confederation, it strips it out on the way out to the other CE, strips it completely out. Now, what's the pros of this? Well, you no longer have that suboptimal routing situation because this is normal, just eBGP in between, right? So this is eBGP, and then eBGP here, right? So you still have the same path manipulation and all that good stuff that you would do in normal BGP. Same stuff. You no longer have to worry about, hey, the route reflector will give me some suboptimal path because it's doing it from, its point of view. The con of this though is setting this up is a pain in the butt a little bit, right? Plus, you just need to know from a troubleshooting standpoint that you're dealing with Confederation and not route reflectors anymore. So now you got to look at other areas in your network to make sure certain things are correct, right? This gives you better route selection because you're just dealing with normal BGP just in just in many clusters. But setting this up, making sure everything is set up correctly, the BGP peering, your Confederate peerings are right, and all that good stuff is where you can kind of mess up at, right? And then you got to get used to seeing this kind of AS path here, right? If you're used to that, then Confederation is not going to be bad. You would probably see Confederation on the service provider side done a lot, and when someone's doing BGP internally, because I've seen that as well, they usually use route reflectors for that, right? Because they don't really have the equipment to set up Confederation within, an internal network. Like they don't really have that, like a LAN campus design or something like that. You really probably wouldn't see um, Confederation there. Now you would see route reflection, right? You would see that. I've seen people do internal BGP, and they have route reflections and they're just connecting stuff like that. But most of the time, route reflection, just BGP period, you're going to see on the service provider side. So from a design standpoint, you're more than likely going to go with route reflection at a certain in a certain type of design. You're going to go with route reflection because you don't have the resources to configure something like this in your network. But on the service provider side, you're probably going to see Confederation a lot. All right, but those are the difference between the two. Why is this important, especially if you're going for your CCIE lab? Because if they tell you to set up BGP with no route reflectors and they show you a picture of what the AS path looks like, and if it looks like this and it has that parentheses there, they're telling you to do Confederation, right? If they show you a picture of what they want at the end of the day and there's no weird AS path, and they tell you that um, you cannot set up multiple peerings, like you cannot use full mesh IBGP, then they're talking about route reflection. So you just got to know how to decipher what they're asking because they're very vague. But if you look at the picture and then you kind of got to guess what they're saying, you can kind of figure it out. So this is Don from Padlock Technologies again. Hopefully that answers your question between BGP route reflection and BGP Confederation. Again, neither are wrong. It's just what are you willing to deal with in terms of, hey, do I want to deal with setting up these Confederate little clusters and then have to worry about AS path and and I have to manipulate within, or do I want to deal with the problem of the route reflector not giving me a optimal path to get from to and from or out of my BGP ASN? So hopefully that was informative. Don't forget to share, comment, like, and subscribe. If you're looking for somebody to just run some ideas to, like you're looking to bring in some like an outside consultant to kind of work with you on your next network infrastructure project, there's going to be a link in the description below. Just click that link. We can start a discovery call, and then I can see if I can help you or not. Again, it all starts with a discovery call because I don't know if I can help you if we don't talk about your next project. Hope you enjoyed this video. Thank you, and have a nice day.